Hello friend, in the series of DAA lecture, till now in previous all video, we already discussed what is mean by spanning tree, what is minimum spanning tree cost, and how to evaluate cost of spanning tree, and what is the properties of spanning tree, etc. Now here there are two methods to minimum spanning tree cost. The first is the Prim's algorithm. Now in last video we discussed how to find minimum spanning tree cost by using the Prim's algorithm. Kruskal minimum spanning tree algorithm. That is, we are going to find the minimum spanning tree cost by using Kruskal minimum algorithm, and we'll also going to solve some problem. So let's start. Now let's first understand what is mean by Kruskal algorithm. Now here we have to find some minimum spanning tree cost, and this is also one of the greedy approach. Now this is the greedy for the minimum cost. So we have to pick the very smallest weight or edge that having the smallest weight, and it doesn't have or doesn't cause any cycle, because the property of property of spanning tree is doesn't holding any cycle in subgraph. Now let's understand how to find the minimum spanning tree by using Kruskal algorithm, or what is the steps. Now the first step is we have to sort all edges in non-decreasing order of their weight. Now as I want to find the minimum cost, so I am going to select the very smallest edge first of all. So pick the smallest edge, check if it is cycle or that particular edge becomes the cycle in the spanning tree. If it is become the cycle, discard. Otherwise we have to choose that edge, or we have to add that edge until we reach the all vertices. Now the properties of the spanning tree, it includes the all vertices without any cycle. So we are going to choose the first the smallest edge, and we have to collect, or we have to make the connected graph of spanning tree. So let's understand it with one example. Using the Kruskal method, we are going to find the minimum cost of this graph. Now first of all, according to the algorithm, we have to select the very smallest edge. Now, or we have to sort the all edges in ascending order. So first of all, we are going to select the first, that is A to B. Now A to B is the first. Now second is the 2. So D to E, that is the weight having the 2. Now after 2, there is a weight 3, that is BC3, and CD having the 4. Now A5 and AC is the 7, and at last we can select A to D. So all we are making the all table, one kind of table having sorted edges in ascending order. Now now you can observe in this table, now AB is the sorted one, or AB is the very smallest weighted edge. So I'm going to select the first AB. So AB is the very smallest or shortest edge from this graph. So I'm going to select the first edge, that is the AB, which is having the weight 1. Now after AB there is a DE. So I can draw this graph like, as I'm going to select the second edge, that is nothing but the E. And this edge holding the weight as a 2. Now you can observe this, this is an disconnected graph. Now in last video, Prim's algorithm, we are going to match, or we are going to calculate the adjacent edges of that particular vertex. Because we are not finding some adjacent or associated edges of this vertices, this make them disconnected. But in Prim's algorithm is an connected graph, because we are finding the smallest adjacent vertices or smallest adjacent edges. So after this DE2, we can select the BC, that is nothing but the 3. So here I can draw the graph like C as a 3. Now this having the weight 3. Now after this CD. Now CD is having the weight as a 4. Now next A to E, that is 5. Now A to, if I join this A to E here, now I'll get some cycle, because spanning tree doesn't hold any cycle. That is, in last video we discussed the property of spanning tree. We don't want the cycle in graph, so we are going to discard this edge AE. That is, AC is having the weight C7, but here you can observe, if I join this edge A to C, it's again form the cycle, so I'm going to discard that edge. Now after that AD that is 10. Now here again, if you connect this edge A to D, it will again form the cycle, and we in spanning tree we don't want the cycle. And here you can observe we got the all the vertices, that is A, B, C, D and E. That is, so I will get the minimum spanning tree. Now the cost of this minimum spanning tree is nothing but the AB plus BC plus CD plus DE. So here the cost of the this spanning tree is nothing but the 10. Now let's understand this with one more example. Now let's consider this graph. Now here in this graph you can see there is a vertices A, B, C, D, E and F having the weight 1, 2, 1, 2, 3, 4, 5 and 6. So we are going to sort this as ascending order. So I'm going to select the first AC as a 1, DF2. DF is the 2, then BE is the 3 and CF having the weight 4. Now after that 5, that is AD, CD and BC. Now you can write it in any order, or ABCEF having the weight 6. You can write it in any order. So to draw this connected graph, now I'm going to select the first edge, that is nothing but the A to C. Now A to C is holding weight A to C, D to F. D to F is also having. Now this make the disconnected graph. But Prim's algorithm doesn't form any disconnected graph. To E is having the weight as a 3. Now after B, CF. Now CF is having weight as a 4. Now after CF, AD is there, which is holding 5. Now if I, you can observe, if I connect this edge A to D, I get the cycle, so I'm going to discard this. After this, CD is having the 5. Now CD, if I again connect this edge CD, again I got the cycle, so I'm going to discard this. Again B to C, if I connect this B to C, I didn't get any cycle, so I can join it, because spanning tree contains a connected graph, so I can connect B to C because there is no cycle. Now after AB to 6, now if I connect this AB, I'll get the cycle, so I'm going to discard CE. After now C is also having the cycle, so I'm going to discard, and E and F. Now where E and F, if I connect this, I'll get the cycle again, so I'm not going to connect this edge. So I'll get this graph as a minimum cost, which having the all vertices A to F, and I cover all vertices. So my cost is 3 plus 5 plus 1 plus 4 plus 2. So my cost of this graph becomes A to C plus DF plus B, CF and B. That is nothing but the 15. So this is all about the Kruskal algorithm. Thank you.